Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 3.1, day 2, entitled Quadratic Functions and Models. And today we're going to talk a little bit more about maximum and minimum values and how you can just find the maximum and the minimum without having to complete the square. And then we're going to apply that to a real world problem. Now, when we are completing the square and rewriting our equation from standard form into vertex form, that'll tell us our vertex and it'll tell us our maximum or minimum value. But if we don't want to complete the square, we can just use a more straightforward formula. And your book shows you how to get that formula. It's basically taking your generic equation for a quadratic function. That's your standard form, the ax squared plus bx plus c. And if you just use those variables and you go through the completing the square process where you take out the a, scooch the c over, then you take half of your middle term, so you have your b term divided by a because they divided it by a, and then you have to take half of that and square it. So you have your b squared, and you have your a squared, and then if you had half of it, 1/2 squared is 1/4. Okay, so that's what you add here, and then you have to multiply that by a and subtract it over here, and then this is going to be your vertex form written out with all the variables. Okay. And that's really kind of crazy. You don't have to worry about necessarily going through that process. You should be able to read through it and follow it and understand it. But what's the main thing I want you to focus on here is this. Oh, not that part, sorry. The other part. Negative b over 2a. That's what they want you to focus on. Okay? Because if you have your vertex, it's going to be the negative b over 2a, and then your b squared over 4a. That's going to be negative 2. Okay, so that would be your vertex. So this value here, this x value or the h value in your vertex, or the x value in that ordered pair, that's going to tell you where to kind of start so that you can find your minimum or maximum value. So that's why that number is so important. That equation is so important. So that is the negative b over 2a equation that they're using right here. And when you learn this in Algebra 2, that's usually what you focus on because that's going to help you find the value for your vertex. That's the x value or your axis of symmetry. Okay? So if you can find that, then you know where the middle of your parabola is, and you know where to start your table. But you can find that without having to complete the square. You just have to know the negative b over 2a. So if you take that value and you plug it back into the equation, then you'll get your minimum or your maximum value out. And that's what they're showing right here. Okay? If you take this value, the negative b over 2a, whatever that is, plug it back into the function, that value will be either your maximum or minimum, depending if your parabola is opening up or down. So let's try this out. Okay, it says find the maximum or the minimum value. And we're going to do this now using that equation. We're not going to complete the square. Okay. Remember, this equation has the x squared plus 4x plus 0. So your a value is going to be the 1, your b value is going to be the 4, and your c value is going to be 0. Okay, so that's important to remember since it's written in standard form. Remember where the a and the b and the c are and how to find them. Make sure it's in descending order. Fill in any placeholders that you might need. And then we're going to use that equation, the negative b over 2a. So that's going to be negative 4 over 2 times 1. So that's negative 4 over 2, which will be negative 2. So that's the x value of your vertex. So now to find the y value of the vertex, you have to take this and plug it back into the function. So you're going to do f of negative 2. So you'll have negative 2 squared plus 4 times negative 2. You could put the plus 0 at the end if you'd like. You don't have to. Okay, so that's going to be 4 minus 8, which is going to be negative 4. And since this parabola opens up, since a is positive, then this is going to be your minimum value. Okay, so that's a faster algebraic way to go through and find your minimum value than it is to go through the whole completing the square process. And you can also speed this up by looking at your table of values. If you algebraically do this negative b over 2a, you know that your vertex is going to be at negative 2. So then go to your graphing calculator and put this function in and find negative 2 on the table of values, and the y value that corresponds with it should be the negative 4. So the calculator can even do that work, the f of negative 2 work for you. Okay, so for part B, we're going to practice the same strategy again. This time, our a value is negative 2, so that should tell us that our parabola is opening down. So we're going to have a maximum value. Okay, b is going to be 4, c is going to be negative 5. So when we substitute into the negative b over 2a, that's going to be negative 4 over negative 4. So that's a value of 1. And then you're going to substitute that back into the equation. So we'll have g of 1 is negative 2 times 1 squared plus 4 times 1 minus 5. So 1 squared is 1 times negative 2 is negative 2 plus 4 minus 5. That's going to be negative 3. So that's going to be your maximum value, again, because this parabola opens down. So it's going to have a maximum. And again, once you do the negative b over 2a to get this value, plug this equation into your calculator and go to your table of values, find 1 in the x column, and negative 3 should be in the y column. So now let's apply this to a word problem. And here we're dealing with gas mileage. Everybody's concerned about this now so that they can save money. It says most cars get their best gas mileage when they're traveling at a relatively modest speed. The gas mileage, M, for a certain new car is modeled by this function. M of S equals negative 1 over 28 S squared plus 3S minus 31. And they give us a specific range, or I'm sorry, domain here for S. It says we have to stay between 15 and 70. And it says S is the speed in miles per hour. So this is the speed that the car has to remain between. It has to go more than 15 but less than 70. And M is measured in miles per gallon. So again, remember, M is the gas mileage and S is the speed. So remember, as you read these problems, take a moment and just make sure you understand what everything is. Okay? So they're asking us to find what is the car's best gas mileage and at what speed is it attained. Now the key word there is best. And since this function that they gave us is a quadratic function, we know that we're going to get some sort of parabola. Our leading coefficient here is a negative 1 over 28, so that tells me that this parabola opens down. Okay, so that means that your gas mileage is going to get better up to a certain point, and then it's going to get worse after you go past that point, if the parabola is opening down. Okay, so if we just wanted to think of that conceptually, like graphically, okay, S is what we're putting into the function, so that's going to be your speed across here. Okay, M is the gas mileage that we're getting out, so that's going to be your y value. Okay, we know it's some kind of parabola. That's probably not exactly how it looks if we graphed it, but let's just think of a parabola for a moment. So as we start to go faster, our gas mileage gets better. We get more miles per gallon. And then after a certain point, we start to lose our fuel efficiency when we start to go too fast. So we want to find that maximum value. That's what this means, the best gas mileage. Okay? That's telling us that we want to find that maximum value. Okay. Now we don't have to take that equation and do all of the completing the square work for that, we can just use our negative b over 2a. So I'm going to do the work here on this next slide. So if we do the negative b over 2a formula, remember a is going to be negative 1 over 28, b is going to be 3, c is the negative 31. It's good to label all of them. We don't need to use c for this function, but it's good to label it so you don't confuse it with a or b. And then we'll have negative 3 over 2 times negative 1 over 28. Now your calculator can handle this, okay? If you wanted to do it step by step, take negative 1 over 28, divide it out, get an answer, multiply it by 2, get an answer, and then take negative 3 divided by that answer that you got. Okay. If you type it all into your calculator in one big string, make sure that you put, at the very least, the denominator in parentheses or brackets. Okay. When you type that into your calculator, you should get 42 out. Okay. Now, remember, what is that? What did we just find in our ordered pair? We found the x part of the ordered pair. If we think of our graph, okay, the x-axis was our s. That was our speed. Okay, so we just found the speed that the car needs to be going at. So this is miles per hour. Okay, but the question asked us to find the fuel efficiency. What is this speed? What is the car's best gas mileage, and at what speed is it attained? So we know that much already. We know half of it. We know it's at 42 miles per hour, but we have to figure out what the best mileage is, how many miles per gallon it gets. So now we have to take that 42 and we have to put it back into our formula or our function. Oops, equals negative 1 over 28 times 42 squared plus 3 times 42 minus 31. So again, you could put that original equation into your graphing calculator, go to y equals and enter it in, and then go to your table of values, find 42 in your table of values. And when you simplify this all the way down, okay, when you take 42 squared, get an answer, multiply it by negative 1 divided by 28, get an answer. That answer should be negative 63. 3 times 42, that's 126. And when you subtract the 31, you should get 32 miles per gallon. So the best fuel efficiency that this car can get is 32 miles per gallon when it's traveling 42 miles per hour. Okay. So if we wanted to write that out in a complete sentence, here it is, 32 miles per gallon when the car is traveling 42 miles per hour. Okay, so like the problem said, you get the best gas mileage when you're traveling at a modest speed. 42 miles per hour is definitely a modest speed. There's not many places anymore on the highway where you're going only 42 miles per hour. Okay, but if it's real important for you to get the most fuel efficiency, you could only travel 42 miles per hour everywhere you went if you really, really wanted to. Okay, probably not very practical, but. So here is your homework for tonight. It's very short. It's only 6 problems. Okay. So some of them are going to be those word problems where you're applying the negative b over 2a concept. So make sure you take a moment, read through the problem, and determine what your x value and your y value are for that ordered pair, for that vertex. Make sure you know what it is you're putting in and what you're getting out. Is one speed and one is miles per gallon, or is one, or are they something else, depending on the problem? So take a moment and figure out what they are before you actually work through the problem. And if you have questions, remember I have all the problems worked out in the binder in my classroom, or come on by and see me before school.